Hello, welcome to CWI Part B Practical Book of Specification Lecture 17. Today I'm gonna start on 5.4.2 bend test criteria. I'm gonna read out the specification and give you the explanation. 5.4.2 bend criteria. Transverse bend specimen should be prepared as specified in Annex 4. Annex 4 is, okay, let's go to Annex 4. This is Annex 4, transverse face and root bend specimen preparation requirements. Annex 4, and here it says face bend specimen, how you prepare the face bend specimen preparation. Here, length and width, radius and thickness, and flush ground. This face bend, so root side, flush ground, and root bend specimen here, and width, length is same, and width we have a width criteria here, and thickness same, radius maximum 3 mm same, and this time root bend specimen, flush ground, the face bend side. And we have note here, this is face bend and root bend, transverse and bend test specimen preparation. Next is the specimen edge radius shall not exceed 3 mm. It is recommended but not a requirement that the specimen grinding direction be parallel to the direction of bending. The specimen edge radius shall not exceed 3 mm. This means, what it means is the radius here maximum 3 mm, and exceeding 3 mm is not acceptable. And the grinding direction of the bend test specimen should be parallel to the direction of bending, but not a requirement. But these two, one, the radius, and number two is the grinding direction, are in the actual CWI Part B actual question, so you need to remember these two. For face bend specimen, the word face side should be on the convex side of the bend specimen. For root bend specimen, the root side should be on the convex side of the bend specimen. Side bend specimen may be bent either direction. For all transport bend specimen, the word meter and heat affected zone should be completely within the bend portion of the specimen after bending. I'm gonna show you what it means. Hold a second, please. Okay, this is root bend side, and the specification says for root bend, the word root side should be convex. So root side here, this is root, and the former, the zig is here and the load is applying this direction, so just bend the specimen bent like this, and convex side here is the root side is convex, and on the other hand, face bent side, root side is here and face side is here, and load is applying this direction, so face bent specimen bent like this, and bent side, the convex side is convex face bent side, and side bent specimen, the load is applying here and bent either direction. And for all transverse bent specimen, the work matter and heat affected zone should be completely within the portion of the bend of the specimen after bending. This means this work matter and heat affected zone should be in the completely in the bent portion. Heads and heat affected zone shall be in the middle of the bent portion. Same thing on the root bent side. Word mirror and heat affected zone are completely in the bent portion, in the middle of the bent portion. Okay, I'm gonna show you the actual question, sample questions. And this time is the grinding direction. I'm not sure if you can see the grinding direction on the picture here on B3. This is B2, B1, and grinding direction is kind of here. And on B2, grinding direction is this horizontal. And here barely you're able to see the grinding direction, but grinding direction is like this. And grinding direction should be parallel to the bent portion, bending direction, and bending direction is this way. Bending direction this way, so the direction of the bending should be parallel, so this way, not this horizontal way, just vertical way is the criteria. This horizontal way is not acceptable. This is not a requirement, but this question is in the actual CWI Part B question, so you need to figure out what the grinding direction is. So simple question is, examine B5 in the face transverse bending specimen. Which of the preparation is not proper? So B5, here you're not able to see the bending direction, the grinding direction, but it is like this way, so the grinding direction is not acceptable. Unless otherwise specified, specimen containing a rejectable discontinuity should be considered as failed regardless of the conformance of the preparation of bending requirements. If the specimen has the discontinuity, rejectable discontinuity, regardless the preparation of from the Annex 4, that specimen is rejected. Specimens not meeting preparation of bending Bending requirements that do not contain a rejectable discontinuity should be disregarded, and a replacement displacement prepared from the original weldment should be tested. The convex surface of the bend test specimen, beginning at the edge of the specimen and including the specimen edge radius, should be visually examined and meet the requirements of 5.4.2.1 to 3. So these sentences are not in the actual CWI Part B exam, so I'm gonna go faster than this 5.4.2, the top paragraph. 5.4.2.1 Structural Steel Application. For acceptance, the surface should contain no discontinuities in the weld or heat affected zone for the following. Acceptance criteria for the bending test is here for structural steel. Structural steel is chapter number 2, workmanship requirement and visual inspection acceptance criteria. And here for the bending test specimen, inspection criteria is 5.4.2.1. Number 1, bigger than 3 mm measured in any direction on the surface, or number 2, bigger than 10 mm, the sum of the greatest dimension of all discontinuities exceeding 0.8 mm but less than or equal to 3 mm, or number 3 is 6 mm, the maximum corner crack except when the corner crack results from visible slag inclusion or other fusion type discontinuity, then the 3 mm maximum shall apply. So let's look at number 1. Like here, you have discontinuity 1, 2, 3, and like here 1, 2. Number 1 says bigger than 3 mm measured in any direction of the surface. So if this discontinuity, length of the discontinuity is bigger than 3 mm, this is reject. But this discontinuity, if this length of this discontinuity is less than 3 mm, is acceptable. That's number 1. And number 2 is bigger than 10 mm, sum of the greatest dimension of all discontinuities but exceeding 0.8 mm but less than 3 mm. Like here you have 3, 1, 2, 3 discontinuities, and the length of this discontinuity is more than 0.8 mm but less than 3 mm. And if this length of this continuity is in the range of 0.8 to 3 mm, count this one as a rejectable. Not yet reject, but count this one. And if number 2, discontinuity number 2 is again in the range of 0.8 and 3 mm, count this number 2. And again, if discontinuity number 3 is in the range of 0.8 and 3 mm, count this one as well. So 1, 2, 3, these three discontinuity, and sum of the length of these three discontinuity is greater than 10 millimeter, then this bend test is rejected. But the sum of the length of these three discontinuities less than 10 millimeter. So for example, 8 millimeter, sum of this length of these three discontinuities, then this is a reject. I'm sorry, this is not a reject, not a reject. This was number 2. And number 3, 6 millimeter. The maximum corner crack 6 millimeter, and corner crack resulting from visible slag inclusion or other fusion type discontinuity. This one, corner crack, results from visible slag inclusion or other fusion type discontinuity. You're not able to figure out what these visible slag inclusion and fusion type discontinuity. So these conditions should be given in the question. So you don't have to worry about how to figure out these two, but just see the corner crack. Corner crack looks like this. This is corner crack. Measure this corner crack length and 6 millimeter and bigger than this 6 millimeter, then corner crack is rejected. But if in the question you see visible slag inclusion and fusion type discontinuity, the criteria becomes 3 millimeter. Measure this one over 6 millimeter, then reject. And if you see in the question slag inclusion or fusion type discontinuity, then the criteria becomes 3 millimeter. This was 5.4.2.1. Structural steel application. 5.4.2.2 pipeline application. Bend test shall be considered acceptable if no crack or other imperfection exceeding 3 mm or 1/2 the specified word thickness, whichever is smaller in any direction, is present in the weld or between the weld and the fusion zone after bending. So this sentence is right here. Like no crack, no crack, no crack, no crack, then these three are acceptable. But if there are cracks and discontinuities like here, but not exceeding 3 mm or 1/2 the specified word thickness. Let's say the word thickness is 10 mm, then the acceptance criteria becomes 5 mm because 1/2 the specified word thickness. The bend test acceptance criteria becomes 5 mm, but you take whichever smaller. So you take 3 mm, choose 3 mm of the criteria, and in any direction is present in the weld or between the weld and fusion zone after bending. Cracks that originate on the outer radius of the bend alone The edge of the specimen during testing and less than 6 mm measured in any direction shall not be considered reject unless obvious imperfections are observed. So the corner crack less than 6 mm is accept unless the obvious obvious imperfection observed. Again, obvious imperfection, you're not able to figure out what the obvious imperfection is just looking at this bend test specimen. So obvious imperfection is given in the actual question, so don't worry about it. This corner crack is bigger than 6 mm, then that's reject. Five point 4.2.3. For acceptance, the surface shall contain no discontinuities in the word or heat affected zone for the following. Number 1, bigger than 3 mm measured in any direction of the surface. So, no discontinuity, that's acceptable, but discontinuities exceeding 3 mm, greater than 3 mm, that's reject. Then if the length of this discontinuity over 3 mm, then reject, and reject. Open discontinuities occurring on the corners of the specimen during testing should not be considered, and a replacement test specimen from the original measurement should be tested unless there is definite evidence that the open discontinuities result from lack of fusion, slag inclusion, or other internal discontinuities. This is definite evidence that open discontinuities result from lack of fusion, slag inclusion, other internal discontinuities. These are, you're not able to figure out what these slag inclusion, open discontinuities, and other blah blah blah, you're not able to figure out what they are. So they should be in the given, in the actual question, but in pressure piping application, this corner crack is not acceptable unless this open discontinuity or slag inclusion, blah blah blah. Other than that, this corner crack is not reject. This bend test criteria, bend test, are very important because like more than 5 questions are in this bend test criteria. So read this bend test specimen criteria carefully and practice how to solve these questions. And tension test criteria. I'm gonna stop here, and for tension test criteria, I will cover this one in the next lecture. Thank you for listening to my lecture. I'll see you next time.